Hello, you're welcome to this lesson. In this video, you're going to learn about Bernoulli differential equations. So if you have a differential equation of this form, where the n is not equal to 0 or 1, then we term this differential equation as a Bernoulli differential equation. If the n is equal to 0 or 1, then we will get a linear differential equation, and we already know how to solve those types of differential equations. So let's look at how we can deal with such a problem. So we have the standard form to be dy dx plus p of x multiplying y equals q of x multiplying y to the power n. So the first thing we'll do is to multiply through by 1 over y to the power n. So I'm going to have y to the power n here so that we can cancel out the y to the power n on the right hand side. So you have y to the power n here, then times 1 over y to the power n. So this will cancel out this, and then at the end you're going to have 1 over y to the power n dy dx plus p of x multiplying y. And then I'm not going to write it in fraction form, so I'm going to have y to the power minus n to be equal to q of x. So I will further write this as 1 over y to the power n dy dx plus p of n multiplying y to the power 1 minus n. And this should be equal to q of x. So at this point, what we are going to do is that we are going to change the dependent variable from y to v. Okay, and our v will be equal to y to the power 1 minus n. So whenever we see y to the power 1 minus n, we can put our v there. But when this happens, we see that we have dy dx here, but we will have to change that also to dv dx. So to do this, we are going to differentiate v. We are going to have dv dx. Okay, and this will be equal to this will be an implicit differentiation. So I'm going to have 1 minus n multiplying y to the power 1 minus n, and now subtract 1 again, and then we bring dy dx. Okay, so now let's simplify this. So when I simplify this, we're going to have dv dx, okay, to be equal to 1 minus n multiplying y to the power 1 minus n minus 1 will give us y to the power minus n, okay, and then you're going to have our dy dx here. So all you have to do next is to make dy dx the subject so that we can be able to do a substitution. So I will write this as dv dx, okay, equals 1 minus n over y to the power n dy dx. Okay, so let's make dy dx the subject. So we're going to have dy dx to be equal to dv dx, okay, divided by 1 minus n over y to the power n. When you reciprocate this, we're going to get dy dx to be equal to dv dx v dx times y to the power n over 1 minus n. Okay, this is what you're going to have. So you can use this substitution in place of dy dx that we have here. So now let's write the differential equation back. We are going to have 1 over y to the power n. And instead of dy dx, we're going to write y to the power n over, okay, 1 minus n, and then dv dx. Okay, this is what you're going to have. Okay, and then plus p of x multiplying y to the power 1 minus n, and that's giving us v. So I bring my v here, and this should be equal to q of x. This should be equal to q of x. So now let's do some cancellation. This will cancel out this, and then you're going to have 1 over 1 minus n dv dx. Okay, plus p of x v, and this is equal to q of x. So now what we have here is a linear differential equation, and we already know how to solve this. So all you do is to solve for v, and then when you get your answer, you change it from you change the dependent variable from v to what, y, because the question gave y, not v. So after getting your answer in terms of v and x, you change it to y and x. So this is how to go about this kind of problems. I'm going to solve an example to help us understand this.